Hello, today we're going to graph simple quadratic functions. A quadratic function is a non-linear equation in standard form written as y equals ax squared plus bx plus c. Today we're not going to deal with the b, so that's why we're calling them simple. You'll only see a coefficient of x squared plus a number. So here's some facts that we need to understand. So we're working with coordinate planes because we're graphing. A quadratic function looks like this. It's that U shape. It's a curve. It's non-linear. There's a vertex to a quadratic function, which is that middle point. It's actually the highest point or the lowest point. In this case, it's the lowest point of that graph. The parent function is the one we always compare it to, and that's y equals x squared. In this case, the vertex is 0, 0. And the last thing is you'll notice it's opposite of each other. It's a reflection of each other, right? So you've got this part of the U, and the other half of the U is an exact reflection of it. So the vertex is always in the middle of that reflection, as well as the axis of symmetry, which means the line that splits those two in the middle. You've also heard of it possibly as the line of symmetry. Okay, so these are all the facts we need to know for this section. Example 1. We're going to graph y equals 2x squared, and we're comparing it to this one, this parent function, y equals x squared. So we're going to first make a table of values. So you have here just standard numbers. I picked them. We're plugging in -2 for x and whatever we get for y, right? -2 goes in for x. -2 squared is 4. 4 times 2 is 8. Then we have -1. -1 squared is 1. 1 times 2 is 2. 0 squared is 0. 0 times 2 is 0. 1 squared is 1. 1 times 2 is 2. 2 squared is 4. 4 times 2 is 8. So notice my output. My range is 8 to 0 to 8. It's interesting. We need this U-like thing. I wonder if we'll get it with this. So step 2 is we need to plot our points. All right. Almost with it. There we go. Is it going to follow me? No. So step 2, we need to plot those points. So we're plotting -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. And you notice here, it's got that curve like to it. So we're going to draw a curve or a U and make sure we add arrows because it does continue up. So draw a nice U as best as you can. And then the last thing to do is to compare to y equals x squared. So it might be easier to add in y equals x squared. What those ordered pairs is, and you'll get comfortable with them quick, you've got 0 squared is 0, 1 squared is 1, 2 squared is 4, 1 squared is 1, and 2 squared is 4. That looks like dead on, but it's supposed to be wider, more like that. All right, so there's my parent function, and the question is to compare it. Well, they've got the same vertex, 0, 0. They've got the same axis of symmetry, x equals 0. AOS is axis of symmetry. And then y equals 2x squared is narrower. See how it goes in the middle there? It's narrower. And hopefully you use graph paper and you can really see that nicely. All right, so example 2. You're going to try it on your own. You're going to graph y equals x squared minus 3 and compare it to y equals x squared. Pause the video and see if you get the same steps, same answer. So step 1, you need to make that table of values. I picked -2, -1, 0, 1, 2, and my output became 1, -2, -3, -2, 1. And then I plotted those points and drew my curve, and it's down there. And now I drew in the red one is the y equals x squared, so I can compare it. Well, it's a different vertex, right? It moved down 3. It's the same axis of symmetry, x equals 0, and it's actually the same shape. It's just shifted down, okay? So we're going to practice this more, but here's the introduction.